Hello, I'm going to walk you through assignment 5 here about the K nearest neighbor. This is one of the algorithms that is brought up in the Stanford videos on learning. This is a classification algorithm where we're going to classify data. We're going to have some data and we're going to try to classify it. It's supervised, so we know originally some data points and how they're classified, and then based on that knowledge we're going to classify some new data points. So there's some simple Java files I've written for you to download here. So download this zip file, unzip it, and import it into Eclipse. So once you're in Eclipse, you should see a source file in the K nearest neighbor project. There should be a default package there, and inside that are two data files, data point and KNN. So let's look at data point first. Data point stores information on our data points. We're going to just use an example classifying some plants. We're going to have the plant height and the plant circumference is our two data points. And then this is a supervised algorithm, so we will know originally with some of the data elements if this is one class or the others. I'm going to use simple classification of trees and bushes here. Now, in reality, this comes from a more complex classification problem that classifies plants based on their satellite imagery and works on about 12 different parameters based on satellite imagery. And what they do is they set up the initial classification and they go out in the field, determine by observation if this type of plant is one type or another. And if so, and mark it all down and do this sort of classification so that they can then classify all sorts of different types of trees and brush by type just by satellite photography. But again, I've simplified this a lot and tried to make it more understandable to you by just using two values, the circumference and height of the tree, and then classify them as tree or bush. So that's the data points under K. Oh, and then the elements here, or the methods, are just a couple constructors and a distance measure. This uses Euclidean distance. This is pretty simple. If you remember distance measurements, we take the square root of the differences squared. So we take, if we're given a new data point that we want to compare to the existing data point and figure out the distance, we take the distance of those two data points, subtract them from each other. I guess subtract the two data points from each other in the x distance, and then square it. And do the same for the y. Subtract the two y values and square it. And then we're going to add those together, sum up the two differences, and then take the square root. So this is where it walks through the Euclidean distance value. Then we have a display function here to print these things out. So most of the work is actually done in this KNN algorithm. And there's not a whole lot here. The main method is here, and so when you open this up and run it the first time, make sure you open up KNN, have that open, and then run it. You can go then and say run as Java application, and it'll run it, and then it'll just print out, it should print out this information to start with. So we just create a set of data points here using the constructor data points. We specify some heights and some circumferences, and then whether or not these are trees or bushes. So we have 3 sample trees and 3 sample bushes in our limited data set. And then you're going to be given a new data point, and this is where you'll change this. You'll try some different data values here, some new data points, and you should test, you should try to classify this as a tree or a bush. Let's look at this more visually. So if I've taken these values, 40, 15, tree, 35, 23, tree, taking those and put those into Excel so you can visualize those, 40, 14, tree, and stuff. So here are the X and Y, the height and the circumference values for our 3 trees and our 3 bushes. And we as humans can easily see that the bushes are all down here and the trees are all up here. But it's really a little challenging to write an algorithm for a computer that'll take some new value and say, should that be down here, or should the, is that a bush or that a tree? In the same ways, when we look at a bush or a tree outside, we can often just see by the size and how big it is that it is more of a tree or a bush. So the question is, if we have some new data point, what should it be? And so let's jump back here. So you're going to modify this and then try out some new data points here and see what they are. So let's just look. Let's put in this 2537 tree and see what that looks like. So I look graphically at this, put in a value of 2537. It's way up here, and visually I can just see it's much more like a tree than it is to a bush. In fact, if I found the nearest value to it, if I measured the distance to every other object in my training set, I'd find the nearest one is a tree. If I looked at the two nearest ones, they would both be trees. So again, we use this term k nearest neighbor because we'll change k from 1 to 5 or whatever. So depending on how many data elements we have. So I might look at the first nearest neighbor or the two nearest neighbors. In our example, we're just going to do the first nearest neighbor and find that out. Now sometimes we will want to do more than the nearest neighbor or the two nearest neighbor. In this example, if I go, here's another data point here, and if I just do the nearest neighbor, it says it's the bush. If I do the two nearest neighbor, it's kind of confusing because one's a bush and one's a tree. And so I might want to do the three nearest neighbors. And as a challenge exercise here, I'll let you try to program, if you want, as a special bonus challenge, to find the three nearest neighbors. But initially, we're just going to find the nearest neighbor. So let's go back to our code and look at that. So right now, what the algorithm does is we've got some new data point we want to classify. We don't know if it's a bush or a tree. And then we have these 6 data points we do know are bushes and trees. And so right now, the algorithm, the code is relatively simple. We just loop through our data array, and we print out the distance to each of the data points. Data point 0, the distance is 23, 18, and so on. We could also change this so it prints out not just the distance, but the type of that data point. So every data point has a type, and we can print that out. So let's just show you how to do that. So I made a small modification of the code here. So now it prints out distance to point I is, and then prints out data sub I dot distance to, which uses the distance to method in our data point. And then I've also added, which is and then I print out data sub I, which is again this data array, dot type, which will print out the type, which is a string, which is this tree or bush value. Now if I run this, it'll print off each of the data points, the distance to the data point, and whether or not that's a tree or a bush. Now if we manually look through here, we can see one's a 23. I want to find the closest one, 18, 12. That's getting pretty close, pretty small. Oh, but here's an 11, 11.1, here's an 11.3, and a 16. So the closest data point, the nearest neighbor, is this. It's a bush. Bush number 3 is the closest. And if we look at our graph, that'll be this bush right here. Let me check to make sure I've got this, I've transposed the values here. I'm looking at 1720, and right now I've got, oops, yeah, I don't have quite the right value here. Let's fix that for you. Okay, so to visualize this better, so I've got this data point 1720, and to visualize that, I can see it's closest to the first bush, which is the third data point. And if I look at my graph here, I've changed my data, so I'm showing this one is 1720. And again, it's pretty close to this tree, it's pretty close to this bush, it's pretty close to this bush. There's 3 elements it's close to, but it is closest to this bush. This is the closest bush. So the first nearest neighbor is this one. So we would classify this as a bush. So again, right now when I run this, it just prints out these values. I want you to change this code, change this loop, so it doesn't print out the distance to every tree and bush. It just says the nearest value, the nearest data point is a bush, and or we estimate this is a bush. Let me just show you how that would work. So now I've commented out and redone this. So this was the original loop. I have another loop down here that I'm not going to show you because that's what you have to do. But when I run that loop, it will tell you that my best guess for the new object is a bush or something like that. So I just wanted to tell you, is this a bush or a tree? And so again, it's going through testing all the distance, finding the minimum distance, and printing out the data type associated with that. And then what I want you to do is go through, let me go back here, we have some different values, a 15, 17, that should be a bush. So I want you to go in here, into the code, put in change this new point to 15, 17, run your program, and it should show that it is a bush. It should say bush. And then try 25, 37, that should be a tree. So go in here and try 25, 37, and see if it should say it's a tree. And do all 4 of these ones. Test out all 4 of these and make sure your algorithm correctly identifies them as trees and bushes. And then you can just submit your Java program so I can run it also. I mentioned as a bonus exercise, if you thought this was relatively easy, it's a good challenge for you. Sorry, no extra points, but kudos if you can do this, to change it so it not just prints out the nearest neighbor, but checks the 3 nearest neighbors, and then sees which of the 3 neighbors the majority kind of rules. So if you have 2 trees and 1 bush, then you should say that the result is a tree. So if you can do that code, that's pretty challenging code. So that's a good challenge, extra credit for you. Oh yeah, and I'm giving you 2 extra credit points for that. Okay, that wraps up this assignment 5, nearest neighbor. Good luck with that.